Right. Today we'll start the paper. First one, asking to find ABC. ABC asking to find so that 1 over 1 plus x, 1 plus x squared equals this given thing, right? Right. Okay. 1 over 1 plus x, 1 plus x squared is equal to b over 1 plus 6 bx plus c divided by x 1 plus x squared. You multiply this by this, right? Bx plus c 1 plus x, right? Now we can equate the coefficients. First x squared coefficient will equate. Here we get a bx and x bx squared coefficient is b. Left hand side no x squared coefficient 0 equals minus b number 1. Right. We'll find x coefficients. Here x coefficient we get b and c, b plus c. Left hand side we don't have x term 0. Constant terms power 0. Here we get a and there we get c. Left hand side 1. And now we have to solve this three equations. Then we get this way we can solve this. 2 minus 3 c and c we can cancel down. B minus c minus 1 a equals minus b. Then we get 2b equals minus 1, b equals minus half. Then a equals by number 1, a equals half. A equals half means by number 3. By number 3 you can write c equals half. A half, c half, b minus half. Now we have to substitute them here, right? ABC, so that's okay. We can write this again, substituting for ABC. Then write that here, a half, that we can write here. B minus half, then we can write minus 1 here, c plus half, 1 here, 2 here. This way you can write. Second one, number 2, y equals x plus 1 over x. We'll square both sides. Okay. X squared, this into 2, 2, 1 over x squared. Then we subject this x squared plus 1 over x squared. Take this 2 to this side, y squared minus 2. Now we'll take the given equation. Given equation is x to the power 4 2x cubed minus x squared plus 2x plus 1 equals 0. We'll divide this by x squared. X squared and here 2x minus 1, 2x, 1 over x squared, 0. Now this x squared and 1 over x squared we can take together like this. By these two terms take 2 out, okay, and minus 1. Now this is x squared plus 1 over x squared, it is y squared minus 2. x plus 1 over x is y, this one, minus 1 equals 0. Let me simplify this. Y squared, here 2y, minus 2 minus 1 is minus 3. We get quadratic equation in y. It is y squared plus 2y minus 3 equals 0. The factors of this we can write. Right? Y plus 3, y minus 1, minus 3, 3y minus. Right. Then there are two answers for y. This way. Y equals minus 3 and y equals 1. Right, now we need to find x. Then first I take equals minus 3. Y is this, no? Then we get x plus 1 over x is equal to minus 3. Multiplied by x, we get x squared. Minus 3x, we can take this side plus 3x, a plus 1. X squared plus 3x plus 1 we get, right? Then we can find 2x values for this x. We can apply that formula, minus b, minus 3, plus or minus square root b squared, 3 squared minus 4 into a into c, divided by 2 into 1. By simplifying this, right, here we get 9 minus 4, it's 5, root 5, divided by 2. We get two answers. One is by plus sign, other one by minus sign. Secondly, now we'll take people y 1. Let y equals 1. Y is this x plus 1 over x, right, which is equal to 1. Multiplied by x squared minus x plus 1 equals 0. Right. People, when I find the delta of this, b squared minus 4ac. B means minus 1, no? Minus 1 square. B squared minus 4. A is 1. C also 1. Here we get delta 1 minus 4. Delta minus 3. Delta less than 0. Then for this quadratic equation has no real roots. Then only answers for the given equation, right? This are these two. Only two real solutions available. No solutions. No real solutions. No real solutions. Right? Next one. Number 3. Given this way, show for all values of theta, the line given by the equation, this passes through a fixed point. Right, so we can write it like this. 2 cos theta, 3 sin theta times 6, 3 cos theta minus 5 sin theta, y minus, within bracket, 5 cos theta minus 2 sin theta is 0. Right, I will take the sin theta terms together first and cos theta terms separately. Right, I take cos theta terms first. I take cos theta out. Here we get 2 cos theta into x, 2x, 3 cos theta into y, 3y, minus 5. We took cos theta out. Next, sine theta terms, right? 3x here minus 5y and minus minus plus 2, 0. We'll divide this by cos theta. So we get 2x plus 3y minus 5 tan theta. This theta is a variable, therefore tan theta also variable. I take let tan theta equals lambda. Then this takes form this 3x minus 5 plus 2 equals 0. Okay. This lambda is a parameter now. Right. Now you can see here, we have here equation of a straight line, and this is also equation of a straight line. You can see these two straight lines are not parallel. How? If the two lines are parallel, xy terms in the equation should be same, but you can obviously see xy terms are not the same. So therefore the two lines are not parallel. Then this takes the form, people. If I take this line as line L1, this line as line L2, then this takes the form L1 plus lambda L2 equals 0. We learned in straight line lesson, this form gives us variable straight line which passes through the point of intersection of these two lines. Right. So then it is well obvious, since these two lines are not parallel, they must intersect. So then by this whole equation, we get the straight line which passes through the point of intersection of these two lines. Since these two lines are fixed lines, the point of intersection is fixed. Therefore, this given line, this one, that means this one, passes through a fixed point. That fixed point is the point of intersection of this L1 and L2. Understand? Then you can write there, this represents an equation of variable straight line, passing through the point of intersection of the two lines (2x plus 3y minus 5 equals 0) and 3x minus 5y plus 2 equals 0. 3x minus 5y plus 2 equals 0. Since the point of intersection of these two lines, is a fixed point, the given straight line passes through a fixed point. Right. Now we need to find the point of intersection of these two lines. Okay. 2x plus 3y minus 5 equals 0. 3x minus 5y plus 2 equals 0. Right. So we have to simultaneously solve these two equations. Right. But we know an easy way of getting this x and y. Right. What is the method? When you find this x, the column containing x we ignore. This 4 we take, multiply this 3 and 2, 6. Then subtract, multiply this 2. Right? Then we get 25. And denominator to get, ignore the column containing the constants. Now multiply this way. 2n minus 5 minus 10 minus here 9. Then we are get, there we get people minus 19 here, minus 19 here, x equals 1. Similarly, you can find y. To find y, put minus sign and then the column containing the y, right, we ignore, then this 4 we get, 2 and 2 make 4, right, minus 5 into 3, minus 15, right, and divide by again, ignore the column containing the constant sign, multiply like this. Then we get this, no? Right, so then we get y, here we get 19, this minus we can cancel down, then y also 1. Then the fixed point is, therefore, the fixed point is 1, 1. Right, fixed point is 1, 1. Right. Number next. Right, now given that cosine inverse x plus cosine inverse x equals 5. So we asking to show x equals half. We can do it like this. Cosine inverse x plus cosine inverse x is equal to 5. Then show that x equals half. Okay, people, I'll take like this. Sine inverse x plus cosine inverse x, right? Sine inverse x plus cosine inverse x. Okay, I'm going to find this sum. Okay, right, I'll take this one as alpha, this one as beta. That means alpha is sine inverse x, beta is cosine inverse x. Take this inverse to this side, sine alpha x cos beta also x. Sine alpha x cos beta x. You can know, people, here we can write this cos beta, I can write sine 90 minus beta. Okay, then this is x, this is also x. Sine 90 minus beta is cos beta coming, equal to x. Now, since this and this being x, you can say sine alpha equals x and this sine pi by 2 minus beta also x, they are equal. Then we can remove sine from both sides. That gives us alpha equals pi by 2 minus beta. Bring that to this left hand side. Alpha plus beta equals pi by 2. What is that? Alpha is sine inverse x, beta is cosine inverse x. This inverse, this implies as sine inverse x plus cosine inverse x, pi by 2. Alright. Now we can do the rest. Like this. The given equation is for sine inverse x plus cos inverse x equals pi. This I can write P sine inverse x plus sine inverse x plus cos inverse x equals pi. But we know sine inverse x plus cos inverse x is pi by 2. Here, pi by 2. Put here pi by 2. Take the right hand side. Pi minus pi by 2. Subject sine inverse x. Pi minus pi by 2 is pi by 2. Divide by 3. Pi by 6. Take the sine inverse to right hand side. Sine pi by 6. Sine pi by 6 is sine 30. Sine 30 is half. X equals half coming like that. Right. Number 5. Limit 0 x times dx minus 1 minus cos x. Right, we can write this way. This cos x we can write 1 minus 2 sine squared by 2. This 2 you can cancel down. Here we get plus 2. No? You can take that before as half. Limit x going 0. We have x cx minus 1 divided by sine squared x by 2. Right, no? Now I can write this half limit x going to 0, right? Dx minus 1, right? This sine squared x by 2 I write like this, 1 over sine squared x by 2 like this. Now here we have x, right? Now I can write people here that x. And I write here x squared. To cancel down that x squared, I write here another x squared. Correct. And also people, I write here 4. To cancel down this 4, I write 4 here. Right. This 4, you can put here. That 4 you can take before. Like this. 4 by 2. 1x you can cancel down with this. Limit x going to 0. Dx minus 1 divided by x1. And same limit I apply here. Over sin x by 2 divided by x by 2 perfect square. Okay. And you know, this limit is 1. This also 1 squared 1. Then we get the answer. Here 4 by 2 is 2. Then the final answer is 2. This way we get the next answer. Right, number 6. Particle is projected horizontally with velocity 25 meters per second. from the top of a building of height 125 meters. Projected with velocity 25. Move this way. By the time taken to fall on the ground, just take this point is A, this is B. For AB motion, we apply S equals ut plus half at square downward. When it comes from here to here, it moves downward direction. This 125. S is 125. Initial velocity horizontally, no downward velocity, 0, u0, half. A, acceleration due to gravity, 10, c square. F5 is 5 seconds. Okay. Find the distance to the point on the ground from the foot of the building. You know this one. Asking. D. We can apply S equals ut, rightward, for the motion from A to B. O, AB motion. Distance is D. U initial velocity 25. E is 5. D we get 125 meters. Find the magnitude and direction of the velocity when the particle hits the ground. You know, when the particle hits the ground, this horizontal velocity never change, no? It has horizontally 25 ms minus 1. Vertically, let us take this as v. We can find this v by applying equation of motion. We will apply v equals u plus at downward. Initial velocity downward 0. A10 T5. We get 50 meters per second. And the velocity is the resultant velocity there. This is 25. This is 50. This is the direction. Suppose the resultant velocity is W. Let this angle be theta. Here 9. W is equal to what? Square root of 50 squared plus 25 squared. Okay, no? But 50 you can write 2 into 25. 2 squared, 25 squared. Take 25 squared out. 25. 2 squared is 4 plus 1. 5. Right. It's the velocity. Direction tan theta. 50 by 25. Theta tan inverse. This we can take that answer. Number 7. The position vectors of 2 points A and B relative to the origin O given this way respectively. Find the vector in the direction AB of magnitude 30. Magnitude 30. Asking, right? Okay, we'll come to that. 2 points given AB, right? I take simply like this, point A and point B. Point A minus 2y plus 4j. B 7i plus j. O is here. Question vector is null vector. Asking what? Find the vector in the direction AB. Alright. AB direction is this. Along that direction AB, there is a vector of magnitude 30. It is asking. Then first of all, we'll find in the direction AB the unit vector. In the direction A to B, the unit vector, we can find vector AB divided by its modulus. Okay. If I take the unit vector in direction of AB as U, it is equal to AB vector divided by AB vector modulus. But AB vector, you can write A to B vector will be equal to quotient vector of B minus quotient vector of A. 7i minus 2y, 9. J minus 4j minus 3j is the AB vector. Its modulus means square root I coefficient squared plus j coefficient squared. Then simplifying this, you can take, we get 81, here 9, then 90, root 90, we get. Okay. Nine I minus 3j divided by root 90 is the unit vector. Now, along the direction AB, there is a vector of magnitude 30. Then that vector we can write vector. Vector is written how, people? Magnitude, its magnitude multiplied by unit vector along the direction of that vector. So therefore, the answer for the first part, you can write any vector, when we write that vector is equal to what? Its size multiplied by the unit vector along that direction. Here we are given the vector has a size 30. Unit vector, it acts along the direction AB, no? AB direction unit vector is this. Then this 30 should be multiplied by this. 9i minus 3j divided by root 90. Okay. Then we can furthermore simplify this, no? Right. I can take this 3 out. 30 into 3. 3i minus j. You can write this as 3 root 10. Okay. This and this you can cancel down. Okay. Then this 30 you can write as 3 into 10. 3 root 10. 3i minus j. Is that required vector? Next one. C is a point on AB between A and B. The point C is this. Alright. See, here we have point. C has question vector t squared plus t squared I tj. Right. Find Tn, the ratio AC is to CB. I take ratio of AC is to CB as 1 is to lambda or 1 is to k. This way I take 1 is to k. Asking Tn. AC CB ratio. Right. Right, now this position vector of the point C, you can again write by using the position vectors of A and B and this 1k. By using ratio theorem we learned. Right, position vector for C, we can write how? 1 into this position vector plus k into this position vector divided by 1 plus k. 7i plus j k times that minus 2y plus 4j divided by 1 plus k. The same position vector only given this way. Therefore, this and that given should be equal. Okay. Then we'll equate this to what? T squared I Tj. Okay. Now, what we do is, this way two vectors are equal mean their I coefficient should be equal and their j coefficient should be equal. Then I am going to equate the I coefficient. Here we get 7, 7 k minus 2k divided by 1 plus k. Right, no? 7 minus 2k divided by 1 plus k is equal to t squared there. Number 1. J coefficient. Here 1 plus 4k divided by 1 plus k. That is J coefficient, right? Number 2. Okay. By solving these two, we have to find what? This k and t. Okay. Right. Now we can put pair here. This t I can put pair here. Right. Or else we can do it like this too. We can divide this two. 1 by 2. One minus 2k. This we divide by this. This 2 will cancel off now. 1 plus 4k is equal to t. Okay. T squared by t is t, no? Then I can substitute this t again in number 2. What do you get there? 1 plus 4k divided by 1 plus k. 1 plus 4k divided by 1 plus k is equal to t, no? T is this 7 minus 2k. 1 plus 4k. Use a cross multiplication this way. 1 plus 4k perfect squared equals this and this. So 1 minus 2k times 1 plus k. Simplify this. We get 1, 16k squared, 8k here. 7 plus 7k minus 2k minus 2k squared. Right. Then take this terms to this side. 18k squared. Here we get 5k. Take this side, 3k. Here, take this side, minus 7, minus 6 equals 0. This way we get, right? 6k squared, yeah, we can divide this by 3. 6k squared plus k minus 2 equals 0. Right, factorize this. We get the factors 3k plus 2, 2k minus 1. 3k plus 2, 2k minus 1 equals 0. Correct, no? Right, so then we get, yeah, k minus 2/3, k half. This k minus 2/3 is impossible because the point C lies between A and B, no? As long as the point C lies between A and B, this ratio of k should be positive value. So therefore, this we reject. So therefore, k is half. K is half. When k is half, you can write ACCB ratio. And t can be found, put in k half here. Right. You see how to take that now? can write SC CB ratio 1 over K AC CB K is half no into that gives us AC is to CB equals 2 is to 1. T can be found putting here. We'll take by 1 by 2. By 2 you can write T 1 4K. 4K means 2 no. K is half no. And 1 plus half 3 by 2. 3 by 2. Then we get T as 2. This 2 we can cancel now. T equals 2. Okay. Number 8 next. A, B, C, D, E, F is a regular hexagon of side A. Forces act this way. Find the magnitude and direction of the resultant force. Right. Regular hexagon. Right, no? Okay. Here's a regular hexagon. A, B, C, D, E, F. Forces act like this. Alone A, B, P, B, C, 2P, C, D, P, E, D, 3P, E, F, P. E, F, P, F, A also P. And AD for this way. Right? This is how we get P2P, 4P, 3P, P, P and 4P. In a regular hexagon, people, you know the exterior angle 60. At a vertex, the whole angle 120. This is therefore 60, 60. Right. This exterior angle is 60. This is also 60. This is 60. Right. When you join this F and C, this is 60. Right. Now asking to find the magnitude and direction of the result. Right. We'll resolve the forces. Solving first rightward. We take X as the algebraic sum. Here we get P, 2P cos 60, cos 60 half. 2P into half is P. Then P plus P. Is 2P plus P. 2P. Here we get 4P cos 60 leftward. Cos 60 is half, no? 4P into half is 2P but minus. And 3P rightward plus 3P. P cos 60 leftward. minus p by 2. Hmm? Next one. Here. This one, 60. Another p cos 60 rightward. P by 2. And by this 4p cos 60. 4p cos 60 means 2p. Hmm? This and this we can cancel down. This and this we can cancel down. We get x by p. Secondly, we will resolve vertically. Take it as y, algebraic sum. Hmm? Right. So then what do you get? Vertical process. We'll take here 2p sine 60 here, 4p sine 60 here, 4p sine 60 here. Right. Then this, this, this. 2p, 4p, 4p. Then we get 10p sine 60 upwards by that process. These two we considered. Another two forces here. P sine 60, right? P sine 60, both down. Minus 2p sine 60. Right. Y. 10p, 2p, 8p. Sine 60 root 3 by 2. Cancel down like this. Y. 4 root 3p. Now the result can be found this way. X 5p. Y 4 root 3p. Result R. This is alpha. R can then be found 5p perfect squared, 4 root 3p perfect squared. P squared we can take out, that is p. Right, here what you get? 16 into 3, 48. Here 25. Then we get 48 plus 25, 73. Okay. Then size is this. Angle also we need to find, no? Direction we need, no? Tan alpha. Y by x, y 4 root 3p, x 5p. This two we can cancel down. Alpha. Tan inverse 4 root 3 by 5. This way we get. We can take it, no? Okay. Number 8 is that. Number 9. ABCDEF is a regular hexagon. Position vectors of A, B, and C relative to a point O are A, B, and C. Show that the position vector at the center of the hexagon is this. Center of the hexagon. Right. Right. A, E, C, D, E, F. Position vectors of ABC relative to point O. People, point O, the vector origin can be somewhere on this plane. We don't mind that. Yeah. And position vector of B is simple B. That of C, simple C. Right. I'm asking, show that the position vector vector at the center of the hexagon. Center means these people. When we join this AD diagonal, this AD diagonal is parallel to BC side then FE side. Also this BE, when we join, BE side is parallel to CD and this AF. And when we join F and C, that passes through this point. That line is parallel to AB and ED. And also people, this all sides are equal. This is the property of the regular hexagon. This point is called as the G, centroid, center. Then you can see there, what people. This AG vector and BC vector are equal. AG vector is equal to BC vector. I'll take the quotient vector of G as simple G vector. Then this A to G vector you can write quotient vector of G minus quotient vector of A. Then G minus simple A vector. BC vector you can write second letter quotient vector minus first letter quotient vector. C minus B. Take this right hand side. G. We get A plus C minus B. This is how we take that. Right, question number 10 next. Two forces F1 given. F1 was given 2y plus 3j. F2 lambda I plus mu j. Act on a particle, lambda mu are constants. The resultant R of these forces is parallel to the vector I plus 2j. Right. How to find the people resultant? Resultant of these two forces, right, will be given by vector sum of these two forces. Resultant of these two forces can be found by vector sum. The resultant, if I mark as R vector this way, R is a now resultant of these two forces, that we can obtain as a vector by directly adding these two vectors. I, we can first add lambda plus 2 times I 3 plus mu j this way. Okay. Is a resultant force as a vector. Right. Now asking the resultant R of these forces is parallel to the vector I plus 2j. Now this vector is parallel to I plus 2j. That means, you know people, when two vectors are parallel to each other this way, one vector you can write as a multiple of other. If this is vector A and this is vector B, these are parallel now, then vector B you can write as k times vector A. K is a real number. Like that we can now write this is equal to lambda plus 2 I 3 plus mu j should be equal to therefore k. K times what? The given vector I plus 2j. Then what is asked in there? To obtain this, right, we'll equate the I coefficients both sides. Right, here lambda plus 2, there k, number 1. J coefficients 3 plus mu 2k. Right. Now by dividing this one by 2, we get what? The required answer, first answer. We get the first answer. Lambda by 2 divided by 3 plus mu is equal to half. Right. Use the cross multiplication, take the terms to one side, 2 lambda. Take here and take mu this side, minus mu. Here 4, here 3, plus 1 equals 0. This way we can take that answer. If force F2 is parallel to vector J, if force F2 lambda I plus mu J, this is parallel to vector J, I can write this as K dash J. Correct now, Vika? K dash J. Right? That means on the right hand side, no I. We get 0 I. Left and right, when I equate I coefficients, lambda should be equal to 0. If lambda is 0, put that here, then we get mu 1. Mu equals 1. Lambda 0, mu equals 1. Now what is asking? Size of R, resultant force. Resultant force is given by this. Therefore, we can write R, resultant force, we have expressed here as a vector, no? Put lambda 0, 2y. Mu 1, 4j. Correct, no? We put for mu 1. This is a resultant force as a vector. Its size only asking. The size can be found modulus of this vector. I coefficient squared, j coefficient squared, root. 4 squared 16, 2 squared 4, 20. Its root, 2 root 5. That way we can take the answer.